This this tonight I asked you guys to tell me how much energy is required to get 200 grams of water to change from a steam at 110 to a liquid at 22 degrees Celsius. Now it would be nice if this was just one nice trend, but the truth is that to get from 110, which is about over there, to 22, which is about over here, we not just have one trend, we have to first make those particles that are steam, we have to first get them down to a level right here that they could actually turn into water, and then over here we have to get all of them to become water, so we have to get them all really close together, and then from here to here. So we have 1, 2, 3 trends to account for. Okay, and that's going to result in 3 for every statements. So we got to calculate the amount of energy here, the amount of energy here, and the amount of energy here. And when we're done with all of that, we can take the energy plus the energy plus the energy, and that'll give us our total energy that we need. Okay, so our first for every statement is to get from there to there. And I told you in class that we needed, for every 1 gram of steam, we'd need to lose 2 joules to change 1 degree Celsius. Now, a lot of you are going to make this mistake, and that is you're going to take 110, you're going to start right over here at 110, and you're going to subtract that from 22. And the problem is that you can't get from here to here. So we got to first get to here. So the only thing that we're looking to change is we're just looking for this to change about 10 degrees Celsius. Not just about, but exactly 10 degrees Celsius. We're trying to figure out how many joules, and we're using 200 grams. Now, I told you this the opposite way, which was that we're trying to heat up the steam. But we need to lose this amount of energy because we're trying to get it to go the opposite way. So if energy is increasing here, we want energy to decrease, which means that energy's got to be lost. Still the same numbers, not a big deal, but just in your brain, you just have to kind of think, okay, I'm losing energy to make it go from a gas to a liquid. So this is going to be times 10, and this is going to be times 200. And I know that everything related to energy, if I need to change more temperature, I need more energy. So those are, if I looked at energy versus temperature, those would be direct. And if I looked at energy versus mass, if I wanted to keep the same change in temperature, those are also direct. And we'll talk about those a little bit more when we come back from break. But for right now, you just need to know that everything that I'm going to ask you to do right now is going to be direct. So this is going to be times 10 and times 200. And 200 times 10 times 2 is 4,000. So now I've got my first E. So this is 4,000 joules. And then our second one down over here is going to be, now I've got to get it from here to here. And so I know that from this one. So I'm going to say for every 2,260 joules lost, we can change 1 gram of steam to water. Okay, and I don't want to change just 1 gram, I want to change 200 grams. So that's times 200. Alright, and you say, Mr. Swistak, this 2,260 times 200, that just seems way too hard. Way too hard. And to that I say poppycock. 2,200 times 2 is 4,400. And then 60 times 2 is 120. So this is 4,520. And then it's not times 2, though. It's times 200. So I got to add 2 more zeros. So this is 452,000 joules. So again, here's my 452,000 joules. So far I'm at 456,000 joules by adding these two numbers together. Now I've still got one more thing to go here, and I'm going to need to erase this here real quick. And I've got my last energy transition here. So this is going to be for every 4.18 joules of energy, there is 1 gram of water changing 1 degree Celsius. Ugh, I need to erase the rest of this stuff here. Okay, so I got to take away again, take away 4.18 joules of energy. Okay, so now I've got, for every blank joules, there is 200 grams, and we're changing it 78 degrees Celsius because we're going from 100 degrees Celsius all the way down to 22 degrees Celsius, which is a change of 78. So I'm going to multiply by 78. I'm going to multiply by 200. And this isn't as hard as it seems, although it is a little tedious on this one, I will admit. So 200 times 78 is the same thing as 200 times 80 is going to be 16,000. And then I'm going to subtract 200. So I'm going to subtract 400 because I was 2 away from being 80. So that's going to be 15,600. And that's going to be times 4.18. And I'm going to be real honest, you should probably use a calculator to figure that out because that's no fun. 15,600, but I do promise I won't give you that when you have to melt Mr. Swistak tomorrow. So this is going to be 65,208 joules, to which I need to add that to that. So this is 521,208 joules is our total energy. Okay, I do hope that helps. You should probably review the video from yesterday. Make sure you know how to make those LOL diagrams. Be sure you know how to read this graph and see that you can figure some stuff out. Have a great one, guys.